I've been waiting for like the second season.
After today, remember you only have 4 notes left. And this one's only 1 page, so not even that bad. Today we're doing the same thing we did Friday. Exactly the same process, same problem, same style, but I'm going to show you how to do it in your calculator so that you don't have to do the tedious entering of the parentheses and the exponents and whatnot. Um, we're going to do this example. And then at the end, I need to show you how to do what's called a follow-up analysis. So that's at the very end today. It's not a big deal. It sounds fancy. It's not a big deal. Okay. Does the warm, sunny weather in Arizona affect a driver's choice of car color? Cass selected a random sample of 300 cars in Oro Valley, Arizona, and found the following counts and compared it to the color distribution of all cars in North America. Okay, so there seems to be like an unnecessary question mark there. I think that's probably supposed to be a period. That's fun. I think what we'll do is we'll take our handy dandy, this guy, and we will go like that, and then like that. All right. Okay, so what we have is we have the cars that she actually found. Cass, I'm assuming Cass is a girl, I don't know. And then we have the claimed distribution in North America. And what I'm going to do in my table is I'm going to show the work in this line, and I'm going to put the expected counts in this line. Normally, I'm not going to show the work every time. You just have to list the expected counts, but I want to remind you of how that goes because a lot of people, the biggest mistake students make on these is that they go 84 times 0.23 and 38 times 0.18, and that's not what you do. Okay, what you do is you take the total, which is 300, and multiply that times the claimed proportion. So out of 300 cars, 23% of them are expected to be white. And go ahead and list that all through here. Don't go to the calculator yet. I'm going to show you my life hack that I do for this. Okay, any questions about what I did so far? Does that make sense? Okay, so we're going to actually start working on the calculator part right away. So go ahead and grab your calculator. And what we're going to do is we're going to use the calculator to do two things at once. So go second stat, no. Just go stat, enter, clear anything out. Get your lists all cleared out. And enter the observed into L1. So I'm going to put a little note that I'm going to put the observed counts into L1. So 84, why is it squared? 84, 38, 31, 46, 27, 29, 6, 39. Do not put the total in there. That would mess up the whole thing. Okay, now this is what I'm going to do. I'm going to enter the expected counts into L2, but I'm going to do it with the math. So I'm going to type the math into L2, so 300 times 0.23, 300 times 0.18. Oh man, the green count was right on. So instead of doing all that math separately, hitting enter, finding all of those things, you need to put them in L2 anyway. So do two things at once. Just put the math into L2. And then come along here. Do you guys have any questions about how I filled in the table? And do you understand why my life hack is saves you time? You got to find those anyway. So you might as well put them into L2 where you're going to do your chi-square stuff. Okay. It says, do the data provide convincing evidence that the distribution of car color in Oro Valley differs from the distribution in North America? This is one of those times when it's just easiest to answer the question. Oh, by the way, I'm going to put a little label here. Okay. The distribution of car color in Oro Valley. I'm assuming it's really hot there, right? That's why they're asking about this?
Yeah.
Okay. Okay. Here. This is not the only way to write the ho and the hop. I think this is the easiest way because I'm just copying off the problem. But what else could you have said? You could have said the distribution of car color in Oro Valley is the same as the claimed distribution. That's what we wrote on Friday. Or you could write P white equals 0.23, P black equals 0.18, P gray equals 0.16. You could write it like that. And then the how would be not equal to, not equal to, not equal to, not equal to, not equal to. Just want to make sure that if you see something different in the back of the book or on my solutions, that doesn't mean that you did it wrong, just means that there's options. Okay. Plan. Chi-square test of goodness of fit. And this doesn't seem that challenging right now, but on Tuesday and Friday, I'm going to teach you two different chi-square tests from the goodness of fit one. And you need to be able to tell the difference. The difference is in this one, it's a list. You have a list and you type that list into L1 and you type that list into L2. It's very important that you see a list there. Because this looks like a table. It is a table, but it's a table of lists. Yeah, just throwing that out, just foreshadowing, throwing that out there. Okay. And probably. Great. 10%? Most likely. Of all cars. Yep. Hey, we already did the expected count, so got that part out of the way. If you don't know what that means, you should probably watch Friday's video. Any questions about the plan? You guys good with the plan? Okay, now, because we're going to do the chi-square in the calculator now and not by hand, College Board still asks you to show your work, but you only have to show the first two terms, then a dot, 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 and the last term. Okay, let me say that again. College Board requires you to show your work, but you only have to show the first two terms, then dot, 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 then the last term. Okay, so first, let's do the white category. So observed is 84, expected is 69. So 84 minus 69 squared over 69 plus 38 minus 54 squared over 54. Are you guys okay so far? See where the numbers are coming from? Okay, then plus dot, 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 plus. And then go to the end, green. 6 minus 6 squared. Oh, I forgot the others. Cool. That's fine. That's why we have white out. $39 minus 21 squared over 21. Okay. All right, now what you're going to do is you're going to make a little box off to the side. See how I put the conclude over here? Okay, so make yourself a little box. This is going to be your calculator instructions box. Do you have to do it with a straight edge? Do you have to make a box around it? No, no, no. It's just that I'm a special lady and I like my stuff to look, a certain way. Okay. Okay, we already did this part. I want to just talk about the word observed. I don't want to completely assume that you guys know that that one means the one from the sample. Observed is the one that you actually saw with your own peepers. You scanned your peepers on those cars. You observed them. Trying to make them remember in a funny way. So when you see observed, that's the one that you got from your sample. That you actually saw, not theoretical. The expected is the theoretical one that you calculated. Does that make sense to everybody? So sample, theoretical. Okay, now this is where I'm gonna have to make some confessions. So I dread this every year. Okay, so there's your calculator instructions, and then what I'd like you to do is follow those. You already did the first two, and then be prepared to just be angry with me, except for that you can't. So. Okay, so you've got your observed in L1, your expected in L2. You hit the stat button, scroll over to tests, and now prepare your fit of rage. They're all in there the whole time. These are all of the ones from chapter 8, 9, 10, and 11. There's all the intervals and temps for chapter 8, 9, 10, and 11 in this menu. Okay. If you need this and don't do it properly, College Board will not give you any credit for having calculator strokes written on your paper. You could have used them to check. I mean, that's fine. They're complicated views. I don't want to teach you that when that's not what College Board wants to see anyway. They're in there though. If you feel bored later in your life, you could mess around with that and play with it. But that's not. But I don't want to teach that way. Now, there's really no better way to teach the chi-square ones. They're all the way down at the bottom. Unless you have the older calculator, then you won't have chi-square goodness of it. Everyone will have chi-square test. If you have an older calculator, you might not have chi-square goodness of it. In that case, you probably want to grab one of mine. You can always do it by hand, you know, with the parentheses, and then do chi-square CDF, which is what they used to do. Anyway, so you want the one that says chi-square goodness of fit golf. It means how close are these to these? How good is your sample compared to the claim? So does it fit your claim, basically? Okay, anyway, so your observed is in L1, your expected is in L2. You do have to enter in the degrees of freedom, which is kind of dumb because the calculator should know that it should just take the amount that you typed in minus 1. Ours is 7. And then go to calculate. Okay, here's the thing. The calculator not only gives you your chi-square statistic, it also gives you your p-value. And it gives you the contributors, and we need to talk about that. So when I said we need to perform a follow-up analysis, you need that bit. But anyway, okay, so what you're going to do is you're going to take your calculator, you're going to set it over here. And then you're going to say, okay, I'm going to take the chi-square statistic and write it here. So that's the top line, 29.92. And then you're going to say on the next line, (29.92) to infinity, 7 degrees of freedom, but you don't actually need to do it because it's already there. It's 9.82 times 10 to the negative 5 So the calculator does the whole do step at once. That doesn't mean that you get to get out of showing it though. Okay. Scooch that off to the side. And remember, scientific notation's always tiny. Doesn't even matter what it is, it's always tiny, which means it's always going to be less than 0.01, which is your lowest alpha you would use. So you always get to reject the null hypothesis with scientific notation. And then go back up to your ha. How mad are you? Are you super mad? Are you full of rage? No, because your teacher wanted to teach you properly. If you take this class in community college, they go heavy into the calculator menu function. And then what happens is you sit down with your stepson and he has no idea what he's doing. It's like, I pushed these buttons, like, yeah, but what did you find? Oh, what's that number mean? Oh, no. Maybe you don't have a stepson yet, but he's in the I don't know stage anyway. Might not be might not be the, I think. So, okay, now interestingly enough, I do want to ask you, what does this mean? What do we find here? What did we prove? What did we say? What did we conclude? What does it matter? Color, yeah, so I'm assuming what they're saying is that there's more lighter color cars because it's hot. That's kind of how I'm picking up what they're laying down. Can you guys tell me what? Can you tell me what you noticed about the first term there? 84 and 69 are pretty far apart from each other, like 15. So that's 17 for the other. Anyway, you can kind of tell just from looking at the differences part whether or not you're going to reject the null hypothesis, because you could see if there's actually something that's off. The green ones, though, the green ones nailed the claim proportion. Does anyone have a green car in here? Like, there are some nice looking like hunter green that I've seen, but other than that, I don't really buy a car that's got color on it too much. Anyway, okay. Last thing for the day, believe it or not. I know. Okay. Perform a follow-up analysis for your chi-square goodness of fit test. You're going to be asked to do this sometimes. Shh. However, it's only worth doing if you reject the hoe. if you don't have convincing evidence of anything, there's no reason to perform a follow-up analysis. Do you guys know that rejecting the hoe means that it is statistically, yeah, statistically. Okay. Well, we get to do that in this case. Okay. What you do is you look for and this is like my favorite emoji, by the way. Do you know that emoji? It's my favorite one. So look for the 2 to 3 biggest contributors. I'm hoping this word will sort of remind you of something from your calculator. Look for the 2 to 3 biggest contributors to chi-square. And that is in the CNTRB section of the calculator. We need to talk about it real quick. So bring your calculator back over. If you have touched any other buttons on your calculator, this is not going to work. If you haven't touched any other buttons on your calculator, you could scroll over through the contributors. Do you know what these numbers represent? Okay, do you know how up here we wrote this plus dot 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 plus this? Okay. Yeah. Just let it make sense. So the first number here is this math. The second number here is this math. The third number here, we didn't write it down, but you know what I'm saying. Are you guys getting what I'm saying? Okay, so each of these are the different categories. Can you guys tell me the biggest two? The 6 one and the 15 one? Okay, and what two categories do those represent as far as the colors go? Other and gray. So it's the third one in, which is gray, and the last one, which is other. Okay, and then you're going to write a sentence for each one of those, comparing the observed amount to the expected amount. Okay, let me give you an example. Gray. There were fewer gray cars than expected in Oro Valley, 31 versus 48. 31 being observed, 48 being expected. Done. Not too bad. Okay, so same thing as Friday, except for you get to cut some corners with the calculator, which is good. Remember, you need to write the first two and the last one for full credit. And you still need to say the p-value equals chi-square CDF, blah, blah, blah. It's just you don't need to do that because it already did it for you. Just grab that number off the calculator. And then follow-up analysis is basically just a more or less statement for your observed versus your expected. You don't have to go deep. It's not like a deep follow-up analysis.